No, what? All right. All right. Welcome to the third lectures of the Introductions to Big Data Ecosystem. So in the previous lecture, we talked about the evolutions of data technologies, right? We talk about when we need to do manual data processing by hands, and we know that hey, when computer arrives, it helps solve many things, right? It helps improve a lot of productivities, and when the database management system arrives, Oracle, right? It also helps improve like productivities further, right? We also talk about when the uh, web is booming, right? That there are multiple users would like to access the same database, right? Um, yeah, we also talk about when the data analytics rise, which is just like decades ago, in which there is a technique that people, since normally when we write an applications, people use a database management system to update, right? To insert small number of data, to select only like some chunk of data, right? And then display it to back to users. That is good if you're creating web applications, mobile applications. You will like each user to update just only small part of your database, right? And then extract only some part of your of the database, not the entire part, right? We call those workload transactional workload, or the OLTP workload, online transaction processing, right? OLTP, right? But database management system that aim for OLTP, typically they are bad at doing data analytics. And last time I showed several reasons why they are bad in doing data analytics, right? For example, the file format, that they are basically based on raw store file formats, right? On the other hand, we have a new way to build database management system, in which we call this variant an OLAP database management system. OLAP stands for online analytical processing. Okay, and with this new type of database management system, they are created specifically for doing data analytics, right? So when we want to do aggregations, group aggregations, um, I mean, most analytics will be aggregations, right? In which we need to analyze a lot of data in your databases, right? They're trying to build specifically for analytics, so they employ kind of like columnar storage, vectorized processings, compressions, those kind of things that help access analytical queries to be fast, right? I believe that is what like the key idea from last time. Okay, if you don't understand the last time, I can say that it will be harder in the futures, right? Because we're gonna build up from that background. Okay, so be sure to watch the video if you don't understand, so that you kind of like get the sense of what this course is gonna be about. And for today topics will be about some things called distributed databases. Last week I also gave you a spoilers, right? That hey, if there are too many users, right? Imagine a Facebook, right? Instagrams, YouTube, there are millions, billions of users, right? Those users access the same server at the same time. Server access databases at the same time. Well, one computer cannot handle it. The number of data pouring into the system. See, there's a lot of data pouring into the system. You know, there's a lot of requests shutting into the systems, and those kind of things make system fails. Right? I mean, I don't think, I'm not sure whether you have encountered this or not, but when I was when I was at KMITL, because I'm also like the alumni from KMITL as well. When we want to register for the course, especially the Gen Ed course that were so popular, we need to steal, right? We need to not steal, sorry. We need to like be very fast. But many people think that many people want to be fast as well. So many people, when the time for the registration starts, many people get into the website at the same time. The server crash. That's happened a lot and a lot and a lot. So basically that means that only one server, one machine is not enough to handle all of this load. Right? That is why today we're going to talk about the way to mitigate those problems by using multiple machines. So next week, Nung, aka อาจารย์น้องหนึ่ง will host a lab on DBT. Okay, so DBT is a new thing that I just add. Nung, are you ready for this? I need to ask you first. Okay, anyway, he will host a lab on DBT. DBT stands for Data Build Tool, right? It's basically a tool for doing ETL, extract, transform, load. If you don't understand this term, go and watch the previous video, okay? I think in the previous video, I think that is one of the very good explanations on what is ETL, right? But if you don't understand, ask on forum, okay? That is the reason why we have forum. You know, I talk about forum a lot, and I really encourage you to use forum a lot. You know, because if we use it properly, that will be a very good place to discuss about stuff, you know. And I don't need to answer all of your questions, like the same questions twice or multiple times. Okay, all right. Yeah, you can see his face here, right here. I stole it from his Facebook. Just kidding. Okay, before we get into the lecture's content, well, I think it's time for the lightning talk. Not the time, but it's time to talk about the lightning talk. Okay, for the assignment number 1, I told you that there are 2 parts of it. The first part is about submitting a boring essay that you need to write. You know, I know that writing an essay is kind of like a boring stuff, but you know, I think it was a good decision that I assigned you an essay, because when you're writing an essay, I can see how you think. I can see your thought process of the way you think about the assignment. You know, when you write each sentence, right, I can see how you link each sentence together, and I can see whether you link it logically or not. You tied up nicely or not. I have graded some of you already, and I think that there are many. So many of you trying pulling out use cases that are not in the books, which is absolutely great, you know, because I also would like you to explore multiple use cases in the world, not only from the book that I gave you. Cool, nice, wonderful. Yeah, but I also spot that some of you may not understand the instruction that I post. But yeah, it will reflect as a score, right? I will try to grade within this week so that you know the feedback as soon as possible. And when you know the feedback, it depends on you whether you would like to improve it or not, because you need to still do the second part, which is the lightning talk. And lightning talk is basically based on the first part, which is the essay. you know. So if you do the essay well, the lightning talk will be very easy. If you do the essay not that great, then the lightning talk will be more difficult, right? So what is the lightning talk? So basically, in the assignment number 1, I asked you to write an essay for 3 use cases, right? Big data use cases, or the way companies, existing companies, use big data. So pick one, not you. I will pick one from what you wrote. Okay, I will be the one who pick it. I will pick one, and then you will use that use case and talk about it for 3 minutes. Okay, in that 3 minutes, I want these things. The first one, I want you to state the problem very well. The problem here. So right now, I believe that it's better if you take a note. Okay. Take the pen out of your pocket or your bag. Right. If you use tablet, prepare pencil, the stylus. Right. So this is what I want from you in the talk. If you just nail these 4 questions or 4 points, you're gonna get full scores. That's it. They will. I may ask some questions if I feel like the talk is unclear. Okay, but if the talk is very clear, then I will ask no questions. So, in which it will be that is the best scenario that you want. Because if I ask no question at all, and I feel like your presentation is very clear, then you will get full score for sure for this part. Right. So in the talk, I expect these 4 things. The first one, I expect you to state the problem clearly. This is not the big data problem. Let me tell you again. This is not the big data problem. This is the problem of why they want to use big data. The original problems. For example, a company doesn't know what to sell to a customer. Traditionally, it's more on the brain of the owner of what the company wants to sell, right? In which it is not systematic at all, right? It's just more like a random guess. State the problems. Then you're saying that, but the companies collect a lot of data, right? Companies have tons of data. So the data here, with a lot of data, you can use them to analyze and predict what the company should sell. Okay, so basically, the predictive analytics is the second bullet point here, or how to use big data to solve the problems. Maybe you need to put on more technical details. For example, I'm gonna pull out the company data and apply some clustering algorithms to see whether which group of product is popular, and then we're gonna try to invent a new product line from that group, something like that. Okay, describe it. Okay, a little bit onto technical, but you only have 3 minutes, so you cannot say a lot of things. All right, you may want to make it relate to the problem that you tell at first. Okay, if it is about company, then try to tie it up with the context of your stories. Right, that is a second bullet point. I want you to say how they use big data to solve the problem that you just stated earlier. Okay, the third one is that the challenge. So in the first lecture, I told you that big data, if you want to use big data, there will be ton of challenges from big data, right? Whether it's from how the volume of it, the velocity of it, or the variety of it, right? I'm sure that there will be more than one challenge. I only want you in the talk, pick one of them that you think that you want to speak the most. not the important, not the most important one, the one that you would like to speak the most, the one that when you speak, you feel comfortable the most. Okay, pick one of them, right? For example, the companies, it store data in many different ways. For example, images, tables, a document, text, audio, something like that. Okay, and then finally you say one tools or technique, only one. Okay, only one that you think that you can explain it well. Okay, only one that you think that you can explain it well. And then talk about it. Talk about how the tools or the technique or the concept can mitigate the challenge or eliminate the challenge that you have just said. Okay? Only these four things in 3 minutes. Is that clear? Any questions, comment, concerns? Oh, each week, starting from 22 December, there will be 10 students per week. Okay? So I hope that it will run for around 5 weeks. Right? Any questions, comment, concerns before we moving on? I believe that if you have questions, then this will be the great time for you to ask me. Okay? Is that clear? Okay? If you're not gonna ask any question to me, let me ask you: is that clear? If it is clear, then show me thumbs up. If it's not clear, then show me thumbs down. Or if you are sad because I asked you for more work, just hit other emojis, sad emojis. No one hit any reactions, means everyone is too sleepy to react with my talks here, right? Oh, at least there is one. Thank you so much. So, there is a questions from your friends. Okay, a question. There is any other criteria? For me, only one criteria that I want is the clarity. You just need to address the correct things clearly. I don't care about other things. Oh, it must be in English, by the way. I don't care about how the grammars. I don't care about the fluency. I only care about the content. It must be clear and correct. Clear, precise, correct. You only have 3 minutes, so you cannot speak you cannot speak a lot. 3 minutes is it's very short. You need to get to the point as soon as possible when you talk. Okay, and that is why we call it a lightning talk. If you have get into some hackathon, it's pretty similar to the elevator speech, but elevator speech, I believe that it is shorter than this. This one, you have a little bit more time than that, so put on more details. Okay, the objective of this, let me tell you why do I ask you about this. Okay, the objective of this lightning talk is not for me, it's for you guys to learn other use cases as well. Okay, so you see why big data is important. Oh, someone will say something. I guess no. It's more like, because if I gonna tell you the big data use cases, I can tell you some, honestly, to be honest. But since we have like 40, 50 students in this class, it is a lot better for you to pick one, and then tell your friends that, hey, this is how people use big data and the challenge that they encounter when they use big data. Okay, that is my objective. I want to see that pictures. Okay, so I would say that I will okay. First, I will send the email to you 1 week before. So basically, you basically have 1 week to prepare for the talk. It's not that much, but for me, 3 minutes and 1 week, it's kind of doable. Okay. I would like you, once you get the topic, at least allocate some time with me. Okay, try and find me maybe after the class, and then talk with me about the presentations, so that I can help you organize the presentations and then check whether the content is correct or not. At least for me, don't let me see the slide. Okay, what I want to say is, make me see the slide before I see you present in the class. Okay, so that I kind of like, I know that the content is correct. Because what I don't want is, I don't want you to say incorrect thing to your friends, right? I mean, if that's happened, then I would need to correct it in the class, and then I need to ask you questions to see whether you understand or not, and that wouldn't be good for you in terms of scores. I mean, it is good for you to correct yourself, right? But in terms of score wise and saying something not correct, I don't think that is good. So find some time, talk to me, okay? So I can help you check, proofread what you want to say, and maybe check the slide if you want. Yeah, just make an appointment to me, at least one. Okay. For the first week, it will be sad because I will be on the plane on Monday, Tuesday, and Wednesday. So basically, you want, but you can Discord me, okay? When I'm in the airport and I can't connect to the Wi-Fi, I will answer your questions, okay? So my expectation is, I want you to deliver the message clearly and concisely, and correct as well, right? So concise means you need to make it compressed without losing any information. Basically, just get to the point as fast as possible. If you work with me for a while, and then you get some feedback from me, one of the feedback that I typically gonna send it to you is that, get to the point as fast as possible, as quick as possible. You know, when you write an essay as well, don't put a lot of things on the introduction part, or don't put a lot of things in the context. I mean, the context is important, but the more important thing is right after that, right? So in a talk as well, you don't have much time. Get to the point as fast as possible. You don't need to introduce to a lot of things. You don't need to spend 1 minute for the context, right? This is not a marketing class. This is a technical class. So I like something. I would like to see some things clear and concise. So get to the point as fast as possible. Bring in key ideas. Use the presentation slides to aid your talk, not as a script. Okay, this is another thing I wanted to say. I don't mind if you're gonna read the script. I don't mind at all. For this talk, okay? I don't mind if you're gonna read the script, but at least please have some eye contact, okay, to the audience. Just don't just be like, hello, today I will talk about. No, don't just be that like this, okay? Make it at least more natural, okay? But I don't mind you have a script, okay? This is not a presentation challenge. I'm not grading you by your presentations. I'm grading you by the content, okay? So I don't want a presentation slide with a lot of text. For third year, you have presented to me at least 2 times. So I think that how I be like, right? Which kind of presentation I prefer, right? For the second years, you only have presented to me only once in the database course. Honestly, in the database course, I haven't give you a lot of feedback on the presentation as the third years. But this is all of my expectations. So what I want to say is make a good presentations, okay? And lastly, practice, practice, and practice. If you haven't practiced and you aim to read the script, well, you may gonna make it, but how you gonna know whether your script works, right? Okay. Any questions, comment, concerns? Any questions, comment, concerns? Everything's clear, right? Clear. Okay. Good, good. Thank you for a thumbs up. Okay, let's get to the technical. Let's get technical. So today it will be the first day we're gonna talk about big data challenge. Well, it's not the first day, but basically it will be the first day we're gonna get into it in details. So you know that one of the property of big data is high volumes, right? And high volumes create challenges. For example, if data are in high volumes, it means that it cannot be fit into a single machine. So when we talk about machine, basically we talk about computers. We're not gonna talk about like a robotic arms machine in the factories, like application specific machines in factories. We're not gonna talk about that. We will talk about computers as a machine. It could be computers, small computers, large computers. I'm treating them as a machine. Okay. When I say the word machines, I mean something that have these two components. The first component is what we call compute. Compute is basically the component in the machines used to compute data, used to run the instructions, execute the instructions. When you write Python programs, the compute is the compute part is all the hardware and software work together to execute each code, the code, right? And that's the compute part. Another part is the storage part. The storage part is basically the part that we use to store data persistently. When we say the word persistent, we means that the data are stored on some kind of a disk devices that when even the machine doesn't have any power, the data is still there. Okay. If you store data on memories, right, like RAM, random access memories, a cache on your computers, once your computers get power off, the power of the computer get off, your data is gone, right? But if you store data on this as a files, then the data will still be there, right? So we call them a storage part. Basically, this the place where data exists for a long time. Okay. Normally in the computers, compute part and the storage part are linked by some interconnection, right? Some of them could be a bus, a wires. Yes, those kind of things. Okay. And yeah, the explanation is on this slide. Compute typically refers to CPU, private memories. GPU could be included as well. Storage typically refers to secondary storage devices, disk, hard disk drives, solid state drives. What else? I think that only these two are popular nowadays, right? There are something like phase change memories, PCM, storage class device, something like that, but it's not popular right now. Yeah, so these are two terms that we're going to talk about it. For the storage part here, it doesn't need to be only a single disk, right? It doesn't need to be only a single disk. It could be, there are multiple ways to craft this storage part. The first one, the most common one, like in your computers, in most of your computers, in most of your mobile phones, your computers, your compute part, the compute part, typically connect to a disk, whether it's going to be hard disk drive, whether it's going to be solid state drive, right? Something similarly to that. Okay. This is most common. We all know it. But in servers, one disk may not be enough to contain all the information. One disk typically 1 terabyte, right? 2 terabyte, 4 terabyte at most, I believe. That is the maximum. If we use it personally, only one person, 4 terabyte is a lot, right? It's too much. It's too much for one person, for one typical person. But if it is a server, for example, Facebook, Instagram, how many photos collect within one day? It definitely exceeds terabytes. So you basically cannot use only one disk to store them. How do they solve it? Those big companies, not just big company. Well, honestly, in Thailand, many companies need to deal with those huge data as well, and they cannot store it within a single disk. So in typically in the servers, in computer servers. Okay, I want to define the word server first. When we talk about the word servers, typically there are two definitions. Okay, for the word server, the first definition is a software server, which is a program that serves something. Programs. It is the first definition is a server for the word server is a program that serves data somethings, data services, so on and so forth. That is a first definition. Okay. For example, if you open up like a game server, right? That is basically a server for the first definitions, right? Where other players can join the server, link to the server and then get content from the server, right? You create a web applications and you have an API server, right? The API server, right, provide APIs to applications, right, to your client-side applications. Those client-side applications connect to the server, connect to the API, because server serves those API, those services to clients, right? That is the first definition. The second definition of the server is the machine that is powerful to handle many users. Right? The machine that is not for personal use, but it's for many people use. Okay? In this point, on this slide, we are talking about the second definition, which is a machine that it is expected to handle tons of users. Okay? So, one of the way to construct storage for huge company, huge applications, multiple users applications, or for server, is to use something that we call a disk array. Many people call it redundant array of independent disks, if I remember correctly. Basically, it is the way to use more disks, multiple disks, to increase storage capacities. So instead of you have one disk, you have multiple disks, but you may need to buy a hardware or a software to control multiple of these. Okay, we call this a disk array managers. Okay, this could be a hardware or this could be a software. It depends on which disk array you use. Okay. If it is a software, the array manager is a software, then we call it a software rate. If it is a hardware, then we call it a hardware grade. Okay. I'm not gonna talk about the rate in detail, but if you want to know more on rate, feel free to talk to me. Okay. Any questions so far? Comments, concerns? But you see, this is actually one of the solutions to let your applications handle big data, right? Well, one of the challenges, the data are in high volumes, right? So we just need to use the area manager plugin all of this. Looking good, looking perfect, you know. But actually, wait, this kind of thing also has limitation as well. But we're not gonna talk about it in detail, and for this class. But I just want to let you know that normally in server perspectives, we use this kind of things. Lastly, I think this might be typical for some of you and for companies as well. So, well, if I need to buy this array, right? I need to so let's say I want to scale up. I want to scale our applications up for handling 10x users, right? 10x user mean that the number of users increased by 10 times. I basically need to buy 10 times more disk, and that would take time and effort to install it, right? So, in recent years, not recent years, it's been here for like 10, 15, 20 years. There is something called cloud, right? Cloud, Google Cloud, Amazon Web Services, Microsoft Azure, right? The cloud is that the cloud basically means they have a lot of machines. So they just let us use the machine temporarily, right? For money. So we give them money, and then they give us unlimited time to use the machine, right? Or unlimited capacity to use the machine, because they already have tons of machines already, right? The good news is that, let's say if, I want to scale up my system, my application by 10 times. If I use the disk array, I need to buy more disk, right? If I use it, if I use this approach, the cloud storage one, I just need to get into the console, the website, and then ask them, request for, can I get 10 times more on this? And then hit enter and wait for a few minutes, and they will set it up for us, right? See, very simple. Because when we work on the cloud, one of the benefits for the cloud is what we call a flexibility or the elasticities. The resources are elastic. It's not a magic, okay? This software, they are software, tons of software help them manage these elasticities. But for us as the users of the cloud, it feels elastic. Whenever we want to use more resources, we just ask them for more. Whenever we want to reduce the number of resources we use, we just ask them for less. Okay? And this is the same things. It's just like our computers connect to some remote storage. A very good example is that a Google Drive. So, okay, my local disk is full. I just throw things in the Google Drive. That's it. If the Google Drive is full, how you do? Buy more, right? There is a subscription that you can expand the Google Drive to be more. Just pay them money. It may not be just, but pay them money, and they will give us more spaces, right? So there are other cloud platform, like for GCP, there will be the cloud storage. This fancy logo, right? This one is the Azure storage, if I remember correctly, or Azure file storage, object storage, something like that. There's one very popular one, the green one, Amazon S3 bucket, right? S3. This is basically Google Drive, but they expose a lot of APIs to make us as a developers or the technical persons easy to use them. Okay, so there are at least three ways to construct the storage part. Okay, any questions, comment, concerns before we moving on? Oh my god, I just get into 14 slide, but we spent like around 40 minutes already. Any questions, comment, concerns? Still follow me, right? You all still follow me, right? Okay, I hope you still follow me. If you don't follow me, please feel free to ask questions, okay? But, okay, so far we talk about singing this, and we talk about, hey, we can add on this by using these array managers, right? Or we can just connect to the cloud to increase the storage capacities. Which mean what? Which mean? Imagine you run a database management system here on this machine, maybe this machine. You don't have any problem about storage anymore, capacity anymore, because you can add more disk. The problem now is the compute, right? Because you imagine the users need to query data, and the one who handle query is the compute. And compute need to access this. So the bottleneck of this process is the compute, because compute handle all the loads, queries, manipulation, whether it's going to be insert, update, delete, all the thing. It's all about compute, right? Queries, aggregations, grouping, sorting, limiting. It's all about compute. So compute is now a bottleneck. It's come to today things that we're going to talk. So first, we're going to talk about two terminologies: vertical scaling and horizontal scaling. And if you still remember it, horizontal scaling is one of the things we're going to talk in this course. Okay. The second one, we're going to talk about challenges in channel thing. What the hell is channel things? Stay tuned. Okay. And then there are two challenges: load imbalance and less availabilities. Each of them have a certain solution. For example, for load imbalance, the solution is to do what we call sharding. The less availabilities, the solution is to do something that we call replication. And again, if you remember replications, we have talked about this in the first lecture as well. Okay? So let's see. It means that if compute cannot handle loads, queries, manipulation as it should, how to upgrade it? Oh, sorry, we need to upgrade it, right? We need to make the compute part more powerful as same as the storage part. So there are basically two ways to improve the compute capacity. Well, as I told you, vertical scaling and horizontal scaling, two ways, right? Vertical means y-axis, horizontal means x-axis. Well, it sounds weird, but let's see what is it in action. But before then, you see both of them have the common words, which is scaling. Scaling refer to how to improve scalabilities. Scalabilities is the property of a system to handle a growing amount of work. We call it amount of work. It is not only the number of users that is increasing, it also the amount of work each user generated as well. For example, today I have big grade, right? I have my big grade. Today, there are hundreds of users. Then next semester, I tell 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 the president of KMITL that, hey, use this big grade for all schools. The number of users rise from 100 to, for example, 10,000, 100 times. That is more amount of work, right? 100 times more amount of work. And we need to somehow upgrade the system to handle them if that our existing system cannot handle them. Okay? That is the number of users that is increased, right? But that is only one case. Another one that could increase or could grow amount of work is, okay, we still have the same 50 users in this class, 100 users in this class, or also for the first year as well. It is possible that, hey, today I assign you 10 work and it due this midnight. So all of you, the last minute, the due date, all of you just hit the submit button and submit like 10 assignments at the same time. That's also another way to increase amount of work as well. So what I want to say is scalability. Many people are going to say that it is about the number of users that is increasing. No, it's more on the amount of work. The number of users increase, true. The amount of work that each user perform is another one. Okay. So let's talk about each terms here. What the hell is vertical scaling and what the hell is horizontal scaling? So for vertical scaling, basically it is to upgrade the compute in terms of upgrading it. So many people are going to say that vertical scaling is basically you upgrade your computers. You buy a faster CPU, you buy a better machine. Yeah. Or another one is you could try to use a more efficient DBMS database management system to handle the workload. That is also fine as well. We call it the vertical scaling as well. What can be the problem of the vertical scaling? Let me ask you this. Okay, it sounds happy ending, right? Oh, so we just buy a faster CPU and then, hey, we now can handle the load. What is the problem of vertical scaling? Expensive? What else? What do you mean by maximum? You hit the limit, right? You hit the hard limit, right? So yeah, both of you are correct. I mean, in case that you guys don't know, I mean, they just send me a direct message on Zoom as an answer. Okay, so the first answer is expensive. True. If you buy a faster CPU, you spend more money. Sometimes when you want to increase the number of, sometimes let's say you want to increase the speed of your CPU from maybe 2 Hz to 4 Hz. I should not use Hertz because frequency of the CPU is not the way to define performance difference. Let's say if you want to increase the speed from 1 to 2 in CPU, you may need to, it may not like the money that you need to spend may not increase by 2 times as same as the performance you get. It may increase exponentially. And that is because of the second reason, which is because there is a hard limit of the hardware that you cannot go beyond. Right? You hit the limits of what human can synthesize the chips, the CPU. Right? So this is what we're saying, that vertical scaling is not scalable. The word scalable here is scale and able, right? It is not able to be, it's not able to scale, right? At some point, right? Because of the limit of the hardware, and it's typically more expensive as well. I should put this one as one of your final exam questions. This should be interesting. Just kidding, it's too easy for you guys. So that is vertical scaling. But on the other hand, horizontal scaling is that, well, if we hit the limit, why don't we just add more compute? You're gonna add more. You're gonna add more machines. If one machine cannot do, then we buy another machine. Put it on. Looks good, right? By the way, now the gray box here, I didn't use the word machine anymore. I use the word system because it is possible that these compute are on different machines, right? But this time they are in the same machine. We just make more compute, okay? And this, I mean, imagine that you have 3 computers linked to the same storage, maybe same Google Drive, right? So you solve the compute problem because queries can be run in any of these 3 computers, right? And if these 3 computers are not enough, buy more. Happy ending. So this is what we call horizontal scaling. So you add more machine, you add more compute. Well, when we actually, the word horizontal scaling, we're not talking about only compute. We can also talk about storage as well. Okay. But on this slide, I only demonstrate to you the compute part, right? How do horizontal scaling on the compute part. So if you look at this system, you can see that all 3 computes, they share the same storage. We call this model share this system because all the computes, they share the same storage, right? They share the same disk. What is the problem with this one? The problem of this one is that, all the compute, they direct into one storage. Imagine all of these 3 computes, they're trying to update the same thing in the storage. It need to wait, right? They need to wait. They cannot process it immediately, right? Or imagine that this storage is basically a computer, right? One machine. You imagine that this storage is basically this one, right? All the compute direct to a single array manager, and the array manager is basically a hardware or software. If it is a hardware, then the hardware itself has the limitation that it cannot go beyond. So you get stuck with the hardware limitations, right? So we call this an I/O. Is a new bottleneck. I/O, input output. I/O stands for input output. We basically use the word I/O to talk about interactions between compute and storage. For example, if I want to access a files on the disk, it means that I am doing I/O action. I'm doing I/O, right? So actually, it's not about only storage. We in computers, right? In normal computers, we have the part of CPU, right? We have the part of main memories, right? Those are the compute part. And what is beyond the compute part? We call them I/O devices, input/output devices. For example, your monitors, that is output device, right? The printer is an output device. Sometimes it could be input. Mouse, it is an input device. keyboard is an input devices. A disk is also an input-output device as well, because you write something onto the disk, that is the output, and you can read something from the disk to the CPU or the RAM, right? So when we talk about the word I/O, we usually talk about interaction between those compute RAM, CPU, and to these devices, including a disk. Another one that we can call it an I/O is the network, because network is something external from CPU and the memories, right? When we access something through the network, we also call the interaction, that interaction, I/O as well. Okay. Okay. So to solve this problem, to solve the I/O as a bottleneck problems, then why don't we just have different storages, right? So each compute have their own storage. Each compute have one storage. Each compute have one storage. Looking good, right? Look nice. And basically, this one means that your system have 3 machines, 3 small machines, 3 commodity machines. When we say the word commodity, it means that it's just a common machine, you know. It doesn't need to be a server grade machine. It can be your PC. 3 PC connect together in order to improve, in order to do horizontal scaling, in order to improve the scalabilities of the system, right? You can see that this one system contains 3 machines. Each machine have their own compute and have their own storage, right? So you follow me, right? I hope you still follow me. Okay. Well, but this one, you have 3 machines. So when the applications interact with the 3 machines, basically they interact through the network, right? Application talk with these machines through the network. When we say the word network here, it doesn't need to be on the, across the internet. Internet is our shared network, right? But it can be the local network, right? You can just like connect these 3 machine and the application together within a single router. That is fine as well, right? Or a single switch. That is fine as well, right? But typically the network here is basically a network of the internet. Okay, so your applications just go through the network and then pick the machine. So we call this kind of system a share nothing system, because each compute doesn't share any disk among each others, right? Share nothing. So there are 2 words here: share this and share nothing systems, right? Share this is all the compute, they share the same storage. Share nothing means each compute, they have their own storage. They are not sharing things. But I mean, looking at the share nothing system, this look pretty nice, right? This look pretty good. So you just add more machine, add more machine, add more machine, and we can keep increase our scale until we don't have money to buy more machines, right? But okay, let me tell you this. To be honest, if you created applications that they have many users, and eventually you don't have any money to buy more machine, it means that your business has a problem. Unless you are creating like a non-profit organization, that is another thing. You need to find small sponsor then. But if you create like a profitable business, you have an application, right? But your application, okay, then you have a lot of users, but you don't have money to buy more machine, then that is a scalability issue from the money point of view. It means that your business has a problem. It's not technical problem anymore, right? Whoa, But alternatively, if you encounter that, you may consider optimize things running on each machine instead. Okay, I don't say that adding machine is the only way. We still have vertical scaling, and vertical scaling sometimes doesn't need to use money. For example, use a more efficient DBMS. You just need to do an experiment to see whether which one is faster, right? And pick the more efficient one to and replace your DBMS with the more efficient one. This doesn't use money. Use time and effort, right? Unless you hire someone to do it for you, that one use money, right? But fundamentally, it doesn't use any money. So, vertical scaling is not bad. For me, if I want to build a system, first you optimize first. You do free vertical scaling first. You do vertical scaling that doesn't use money first. That doesn't use money first. And if you cannot do anything more, then you compare whether you should do vertical scaling that use money versus you add more machine by doing, which is to do horizontal scaling. And you wait, right? If do vertical scaling is cheaper, why not do it? But if do horizontal scaling is cheaper, then go ahead do horizontal scaling. Or maybe you expect that, hey, I can do vertical scaling right now, it's cheaper, but in the future, I eventually need to do horizontal scaling. Then yeah, that at that time you may decide to do horizontal scaling. So it depends on the decision. But you need to know. You need to know when to do horizontal scaling, when to do vertical scaling. Okay. Oh my god, I talk about it a lot. All right, clear? Anything? Any questions, comment, concerns? Do you understand me? Are you still following? Or you just like too sleepy and then get sleep already? Get slept. Someone still understand me. Good, good. I'm so glad. Right? So, for sharing of things, this look pretty nice. This look like a silver bullet to the scaling. But yeah, we mitigate I/O bottlenecks, but there's still several challenges. I'm gonna address two challenges in the share nothing systems. The first one is the load imbalance. The second one is less availability. The load imbalance, you may have heard it in what AI when you train model data. The label of the data are the data for each label are the data for different labels are not balanced, and eventually you train model and model get biased into one label, right? We're not gonna talk about that. That is not about AI. This is not about AI. This is about load. Load. When we talk about the load, we talk about the workload that your users of the application or user of the system flow into your system. Okay. The next one is less availability, in which I will describe the word availability later. Okay. So let's get to the load imbalance. It is now 10:19. So, okay, I guess before we get into it, let's have a break, 10-minute break, and we will get back together 10:30, okay? Okay, because I'm gonna grab a drink. Be right back. Break, 10-minute breaks. Let me write. Okay. recording. Okay. Right. So, just to recap what we have before the break. So we have this, right? We have talked about the share nothing system, which is basically one of the way to improve the scalabilities by um, a system that use horizontal scaling by adding more machine where compute and storage where storage are not shared, right? Compute are not shared among system, among machines. Okay. But even though we can mitigate the I/O bottlenecks, there are more challenges. Load imbalance is one of them. Let's talk about the load imbalance one. Load imbalance is what? Imagine that one machine contain a very hot data. What do I mean by the hot data? So imagine your YouTube videos, YouTube, and then suddenly there is one video that is more popular than the others, like significantly more popular than the others, and every single people in the world just watching this video within a very short time, and this video is accidentally in a single machine, which means all application, the load, users still get into the same a single machines, right? This one, it's only take this path. All the load, 90% of the load. Let's assume that it is 90%. Take this path. This machine crash eventually, right? Because our horizontal scaling doesn't help anymore because with 90% of the load still get into one machine. How to solve this? Well, one of the ways we can try to partition this database across multiple machines evenly. So I think the videos, imagine, so the example is that we have one video that is very popular, right? Well, that might be, I mean, if that's the case, then I believe that another technique might be better. But for this one, it's more like a set of videos. It's not only a single video, a set of data or a set of videos, a collection of videos. They are more popular than the others, right? So these popular videos should be spread across multiple machines, right? Or basically, the hot database should be partitioned across machines so that we distribute the load evenly. And we call this, sometime for some system, we call this sharding. For example, we have this select statement. You still remember this, right? We're trying to pick all the rows from the table, namely hot, where the ID mod2 equal to 0, which basically where the ID is even, right? Is even. So across machines, the first machines, we contain ID, it contains ID 125. The second machine contains ID 378. The third machine contains ID 469. Which means we access the first storage, right? And we access the first storage to get number 2, right? We access the second storage to get number 8. we access the third storage to get number 4 and 6. This is another problem. Okay, you saying that the hot data should be spread. I say that the hot data should be spread evenly, right? Oh my god. I say that the hot data should be spread evenly, right? But what if there is a query like this, and when you spread data evenly, you get the problems that there are multiple round trips, right? You see that only for this query. Oh my god, I forgot to remove my drawing. You need to, you guys need to notify me about this, okay? Notice me about this. So you see that what I want to say here is that if, okay, good that you partition data evenly, right? But is that the answers? Is that the solution? Because for me, it's all about the queries. If you got a query, if you got a query like this, oh my god. Oh my god. Let me change to laser pointer. Okay. If you got query like this and you partition data like this, means that for this query, you access 3 machines. Right? All the machines need to compute the same things, the same queries. Do you want that? So what I mean is, it's not just that you can randomly spread data evenly. You need to spread data, partition database with a strategies, with a good strategies. So to reduce communications. Communication is one of the very important costs in computing. You know, if you reduce the number of computations, it is likely that you're gonna reduce the execution time by a lot. For example, you partition this. You see, these partitions are not even. But if you know that you're gonna get this query like 40% of the 50% of the time, like 30% of the time you will get this kind of queries. Then all of those 30%, you only need to use 1 round trip for it. Okay. So you see that there are different trade-offs when you partition data, right? You need to consider multiple factors. You need to consider whether the load is imbalanced or not. You need to consider when after you partition the data, whether you optimize the communication cost or not. You reduce the communication cost or not. You're trying to minimize the communication cost or not. So let's talk only about tables. Okay, database, that is tables, relational database management systems that we store a database as a table. There are basically 2 ways to access to partitions table. Again, we still see the word vertical and horizontals, right? But this one is not that hard to guess. For vertical partitioning, it is like you have this table, you partition it by column, just chunk it, cut it, chunk it. That's it. The good news is, if you know that one queries, one group of queries only access the first 3 columns, and another group of queries access these 2 columns, then you would distribute the loads evenly. And each query only need to access 1 machine, right? You see? So partitioning is another thing that it's just like an art of design. You are designing the partitioning strategies carefully, then you save a lot of cost. you know. Another one is horizontal partitioning. So vertical is you partition it by columns, right? For horizontal partitioning, you partition it by rows instead. And this is most common and most popular one because normally you typically would like to have so many queries trying to access multiple like data from multiple fields in one row, you know. And if you so let me say it in this way. For me, if the query is OLAP, online analytical processing, even you do this, it is not good because for OLAP system, you would like multiple compute to help you compute. You know, you want multiple compute to help you compute so that you reduce to make it fast. Imagine that you want to find sum of types here and you do vertical partitionings. Only this machine can find the sum of type, right? But if you do horizontal partitionings, you have two machines help you compute the sum of types, right? So this is another thing. You see there are tons of factors going on here, you know. For the OLTP, you want queries, you want entire rows. Frequently, you're gonna want entire rows, and if you partition it vertically partitioning, basically you need to grab this row and grab this row from two machines, and this is not efficient. So most of the time, we do horizontal partitioning, even though it is OLAP or OLTP. Okay. Well, I need to tell you first that these 3 round trips. Let me get back to this one. This one, 3 round trips. Sometimes it may be bad, but sometimes it can be good as well. You know, so if you want multiple compute to help you compute things, and having 3 round trips may be good, maybe better. But if you only want a small data, just only small piece of data, then you don't want a lot of round trip. It's more like if the communication cost worth, then having multiple round trip is fine. Okay. I think this is a little bit confusing, but if you still have questions about this, post it on forum, or if you are not comfortable, I still want you to use forum, okay? But if you're really not comfortable, I will be on site soon, so ask me, note down the question, and then ask me when I am on site, right? So most common thing is the horizontal partitioning, even if it is OLAP or OLTP, okay? For horizontal partitionings, there are multiple strategies, and I will talk about the first 2 strategies, and then I will touch a little bit on the third one and the fourth one, okay? Just only a little bit. Ranges. What do we mean by ranges? When we want to partition some things, we typically gonna have one column as a pivot, and this pivot, we use it, we will call it a partitioning key. Partitioning key will be the values that we will use to determine whether that row will fall in which partition. For example, this one, I use type columns as a partitioning key. And the partitioning strategies or the partitioning method they use is ranges. Basically, ranges is that I say that, hey, for the first partitions, I want the type from 1 to 2. For the second partition, I want the type from 3 to 4. So it's we specify the valid values for each partition as a range. Okay, and then we just kick the first row, put it into the left one. Sorry, the first row here type is 4, so we move it into the second partition. The second row type is 1, so we put it in the first partition. The third row the type is 2, we move it to the first partition, and the fourth row the type is 3, so we move it to the second partitions. Right? What is a good thing for ranges? It depends on the queries. If you receive the queries that, hey, this small, like the type 1, 2, if you receive a queries that the type 1 and 3 are very hot, then you may not, you don't want 1 and 3 to be in the same partitions, right? You may want to use the way that 1 and 3 are separated, and ranges is one other way. Or maybe you may say that, hey, some of the queries we focus on some of the queries we may focus on the same salary ranges, right? So we may want to if you want to find a person with the same salary ranges, if you want to focus on that, then if we have a range of salaries that we are interested in, then we may check whether this range fall into which partitions, right? And then we only need to consider those partitions. Okay. Another one is a hashing strategies. But before we get into the hashing strategies, well, we need to get some refreshing first. Not refreshing for some of you, but well, we need to talk about hashing function first. The hashing function is it's typically a one-way function that produces a fixed size output. What do I mean by that? One-way function means that you translate from one input into output that you cannot convert it back. You typically cannot convert it back. Okay? And produces a fixed size output means the output is guaranteed to be in a certain range. Yeah. For example, a hashing function of fx equal to x mod 128, right? 128. So if you consider this function, the output can only be ranging from 0 to 128 inclusive, right? And that is a size, the fixed range of the output. So we call it fixed size because 0 to 128, when we store it in computers, it takes like 0 to 127 to 8 is around. We need to use 7 bits, around 1 byte, to store this data. So that is why we typically call it a fixed size. Okay, so basically, it must be guaranteed to be in a certain range. It cannot be random. Okay. So if we do hashings, then we may define a hashing function. For example, this one, we do our hashing function is x mod 2, and 2 is typically going to be a number of partitions. So if we use type as a partitioning key, then what's going on is that we first use get the values from type, right, and then put it into the hashing functions. For this one, for mod 2 is zeros, right? Zeros means it will fall into partition 0. And let's assume that it is the first partitions, right? And then the second one, type 1, right? Oh, I guess it's a little bit swapped. So for mod 2 is 0. So actually so let's say that this partition is partition where hash value is 0, and this is where hash value is 1. Let me put it down. Okay. So 4 mod 2 is 0, so it falls within the second partitions. 1 mod 2 is 1, it falls within the first partitions. 2 mod 2 is 0, it falls within the second partitions. 3 mod 2 is 1, fall into the first partition. Something like that, right? Looking good. We're trying to spread data evenly, right? The bad thing about hashing is that for ranges, you see it has some kind of semantics that could help you out, right? But for hashing, it doesn't have any semantic. We're just trying to break down data evenly, right? So mostly if you use hashing, you try to assume that all the data are equally important, most of the time. Another problem for the hashing is that, let's say now 2 machines are not enough. 2 machines are not enough for storing data. How are you gonna do? You add more machine, right? You add the third machine. Okay. Then I add the third machine. When I add the third machine, my hashing function must be changed, right? Because mod 2 is for 2 partitions, and mod 3, and if we add the number of, if we add more machines, and the number of machines change, which means the number of partitions typically going to be changed, right? From 2 machines to 3 machines. So we change from mod 2 to mod 3. And if we do mod 3, then it means that all the data must be reorganized. We need to rehash each one and put it into the appropriate partitions, right? So from mod 2 to mod 3, then we need to rehash it. Okay. So this one is hash x is 1, x is 2, and hash x is 0. Okay. Now we rehash everything, right? We need to reorganize everything. 4 here is 1. So it's 4. So the first row here fall within the first partition, in which before it fall within the second partitions, right? So basically you cannot rely on the same old partitionings. You need to repartition everything again. You need to redistribute all the data again. And this doesn't work well, doesn't look good. Let's say you have billions of rows, right? You are Google. You have billions of rows. I want to add one more machine. I add it. I change hashing function. Everything broke. Everything fall apart. I need to rehash those billions of data. We're not gonna have time to do that, right? As a huge company, you're not gonna have time to rehash all the data, to redistribute all the data. That is not efficient. So one other way to deal with it? One other way to deal with it is to do consistent hashing. Consistent hashings. Basically, first, your hashing function, the number here doesn't need to be, the number here, it doesn't need to be the number of partitions anymore. Can be anything. But it should be more than the number of partitions, okay? Let's say I use 4. And first, I break, and then mod 4 means that the possible values from the hashing function can be 0, 1, 2, and 3, right? Can be 4 possible values. So for each partitions, I put on the condition that, hey, you can fall into the first partition if you get 0 to 1. The hash value is 0 or 1. Right? And if the hash value is 2 or 3, then it falls into the second partitions. Yeah, and I think that's the slice wrong. I may need to change this one to so 4, right? Type 4 here should be this one. Let me change it to 4. Let's change this to 3. Okay, so you see, so now it sounds like it is hashing and range hybrid, right? But you need to see this first. So okay, you can distribute it like this, like normal, right? But when, okay, so it sounds like hashing plus ranges, but how does it fix, how consistent hashing fix the rehashing issues? So when you add new partitions, what you do when you add new partition is that at first this is hash equal to 3 to 4, right? Then when you add new partition, you divide the range of the hash output and then send it to this one and then send it to the new partition, which means these partition will still be the same. It's just that this partition that you borrow some ranges and give it to the new partitions, this one need to be rehashed. Right? Because you borrow some ranges and give to this guy, to the new partitions. This one, no need to rehash. Right? And this is what we call consistent hashings. If you check it out on internet, it will talking about hashing ring like this, 0, 1, 2 zeros. Well, the concepts are pretty similar. Okay, the concepts are pretty similar. Check it out, but it will be more technical. Okay, I just trying to make it easy for you to understand. Right? Any questions? I think this is kind of like very technical. You just need to know this is techniques, right? Consistent hashing is a technique. What, which problem does it solve, and how does it do, right? Any questions, comment, concerns? Okay, let me clean up the drawing and then continue. So that is the first one, load imbalance, right? So load imbalance, we try to fix it by distribute the load, the data evenly, right? But we still need to consider that for some small queries, you may want to pack data, similar data, onto the same machines, so that you reduce the number of round trip. But for a query like an analytics queries, right, you may want to distribute data that multiple machines can help you compute it. So you see, they are different trades off that you need to think. And to distribute data, there are multiple strategies. People typically do horizontal partitioning, and within horizontal partitioning, there are multiple strategies like ranges, hashings. For hashings, if you want to make sure that you don't need to rehash a lot, then you may want to use consistent hashing technique, right? They also round robin, which round robins means that, okay, the first data, I don't know, we don't have partition key, we just put, okay, the first row just insert it, put it onto the first partitions. The second row arrive, put it on second partition. The third row arrive, put it on third partition. Then when the fourth row arrive, but we only have 3 machines, and we get back to the first machine, second machine, third machine. first machine, second machine, and third machine, like this. That is what we call round robin, right? The last one is a predicate. The predicate here is that, when we write a select statement, right? What in the where, the condition in where, we call them predicates. So predicate, partitioning by predicates means that you use predicate. If this row fall into this predicate, you put it onto these partitions. If this row fall into this predicate, then you put it on this partition. This will help you, let's say, when you get query that have a predicate, you only need to access one machine, right? Okay, maybe you need, it's good to know many strategy, because you're not gonna know whether which kind of workloads you will be encountered, right? You will be encountering. Right, the next challenge for doing in the shared thing system is about layers availabilities, right? So it's good that you have multiple machines. Database is distributed across multiple machines, but you have multiple machines. It is more likely that some machine will be broken. Let's say you have 100 machines in 1 year. What do you, okay, when you have one machine and 100 machines in 1 year, within 1 year, do you think one machine, what's going to be the likelihood that one machine will fail versus one of the 100 machine will fail? At least one machine will fail among 100 machines. The second one sounds more likely, right? Because it's just like, we just need one out of 100 to fail, right? So there is a quick mathematics that you can use called the MTBF, mean time between failures. So basically, but actually mean time between failure, we talk about something that we call reliabilities, but yeah, we'll revisit it later. But what I want to say is, if you have more partitions, actually not partitions, more machines. When we talk about partition, we typically talk about data. In the same machine, you can also partition data into two. You don't need to partition data and then put another partition onto a different machine. You doesn't need to do that, or you do not need to do that. Okay, partition is about distributing, like grouping data, but distributing data across machine is your choice. Okay, when you distribute data across machine, we call it sharding. Okay, so the more, honestly, I should say more machines, that will be more precise. More machines typically gonna give you less availabilities. Availability is a probability that the system will work as required when required during the period of a mission. So it is a likelihood of a system that will work as required. If a system is not available, it means that you cannot use a system as required. Okay. There is another term called reliabilities. These two terms are pretty similar. Reliability, we talk about the likelihood that the system will work as expected. So availability is as required. Reliability is as expected. Okay. So why do we need to talk about availabilities? So let's think about that. A typical computer could last long for 3 years before it failed. Let's say that your system has 3 computers. It is typical that in 1 year, one's computers within these 3 computers will fail. But if you only have 1 computer, it is likely that this computer will fail within 3 years. And if one of the computers fails, will your system fail? If you distribute data across all of these three, maybe or may not, right? But definitely some of the data will not be accessible. If those data are very important, then game's over, right? Game's over, right? We don't want it. We don't want this to happen. So how do we improve this numbers? How do we make sure that, hey, if one machine die, the system doesn't die? We do replication. We do data replication. We replicate data. What do we mean by data replication? So we do, let's say we have one machine. Then we copy data from one machine to another machine. If, let's say, we lost one machine, we lose one machine, we still have another machine contain the exact same data, and user can still access this data, right? So this is how you improve the availabilities of the system. But you really need to ensure that these are in syncs, which means, let's say this. Oh my god, no one noticed me that there's still like some drawing on the board. Okay, so let's say I say that, hey, A deposit money, maybe deposit $1,000 to the first machine. Okay, to the first machine. So in the first machine, I have A. Let's say it already have they have $10,000, and then the copy it also say that A have $10,000, right? Okay, A deposit money 1,000. Okay, it updating it from 10,000 to 10,000, 11,000. But before it gets syncs, somehow this one crashed. The machine crashed. What's going on here is that data here doesn't get updated. A lose free $1,000. A now crying. Right? A crying. They lose $1,000. Right? Do you want this to do you want this to happen on your system? No. Okay, you improve availability, that's cool. So it means that these two must be in syncs. One of the way, it's not gonna be in the slides. One of the way is that you use transaction. Transaction, if you remember, we have a atomicity, right? Atomicity saying that all or none operation must be done. You transactions and you ensure that all updates must be written. Normal transaction will ensure one storage, but in some database management system, it offers something that we call distributed transaction that will allow you to ensure that if A get updated, other must get updated. Or let's say if this is fail, then these must not be updated and get rolled back. Okay, when it get rolled back, then it must be something. Let's say to user that it is wrong, it is in errors. You cannot the process doesn't end well, so it get rolled back. Everything get rolled back from the beginning, right? Distributed transactions. If you want to do it, I will. This is not a very technical part. This lecture is not. I will not get into the technical detail for the distributed transactions. If you want to know more, there will be a technique. The first one called 2PC, 2 phase commit. If you want to know about this more, you need to understand right ahead locking. If you are second year, I think you may have heard this word in the database course that I taught you. Right, another one, you may use some consensus protocol to make this, to ensure this kind of things. There are two popular one called Pasos. The Pasos one is a very old one. There is a new one called Raft. I believe that they work differently. You may need to read about it to see what are the pros and cons. Okay. Well, again, I'm not gonna get into the detail of the distributed transactions. I just want to say that there is a problem if data are not in sync. Right? And this typically be because of the delay of syncing. Oh my god. So the delay causes consistency to be cause data to be inconsistent for a while until it becomes consistency. So until the primary machine, the first machine get go up, something like that. It will be consistent. It will be eventually means that after the sync delay. So many distributed database management systems, it guarantees eventually consistency. So we need to wait for the sync time. If you don't want this, then you need to use distributed databases that provide you distributed transactions, those kind of things. Okay. But if you're gonna use database that give you eventually consistency, then don't. For some application or system like banking system, that they require strong consistency, means that data must always be consistent. We do not accept if it's not consistent at all. If that's happened, then for like example the banking system, that we must ensure that all the copies must contain the same things. Don't use database that provide you eventually consistency. Use database that provide you strong consistency. Okay. I forgot to tell you another problems for syncing things. So when we talk about banking, right? Again, I will tell you the same scenarios. A deposit 1000, it get updated here, right? But things is this. So someone read data, read balance from A. Someone want to deposit. B, transfer maybe 500 to A, right? But this is before the syncs. So what happened is that A get updated. Into this amount of money, right? So now data are inconsistent, right? Data are inconsistent. So let's say the problem is, which one should we trust, right? Which one should we trust if this happens? So that's why most of the time, systems, this kind of system that allow us to have like multiple replications, replicas, they only allow one machine to do read and write, and other machine to do read only, to ensure this. Okay. All right. So that is another thing I would like to describe on this slide. There's another thing as well. Another thing is that it's about the delay as well. Okay, we say that this one is read and write, this one is read only. Cool, wonderful, right? But okay, then okay, let's say I update it into 1010 because 11,000 because A deposit $1,000, right? But what if B what if on that day A would like to buy something, the price is 10,500, but the applications that A would like to buy only access these database and keep telling A that, hey, your money only 10,000, how could you buy this, right? But actually A already deposit money, but 1,000 already. So basically A should have enough money, but it's just not in syncs, the delay. And this delay, if you are not synced properly, if you are synced like only at the midnight, then it means that A need to wait for 1 day until they can buy it. They can buy this stuff, right? So see, there's tons of challenges. So think about it carefully. If your system cannot endure that the eventually consistency things. Eventually consistency thing is that what I tell you, that it is not synced immediately. Data are not in sync immediately. If your system, like banking, that requires some consistency, means that read must show the recent update always. Then you should not use database that guarantee you eventually consistency, right? You may need to use something else. Okay. Another thing that I need to talk is that, okay, since we have multiple machines, definitely some will fail along the way. For example, and the bad thing is, if the primary one fail, which means in this data, this partition of data, no data can be written, right? Because primary is the only one that can read and write, but the other can only read, right? Now the primary fails. So how do I write onto this data, this set of data? How? which means we need to elect the new primary. To elect the new primaries, basically they do vote. They vote, right? In the quorum, right? They vote. So they vote. Okay, and check the vote count. So if somehow the vote count are the same, then they need to re-vote it until there is one machine getting more vote than the others, getting the majorities. Let's say for this example, the secondary number one got the most vote. So the secondary number one will be the next primary, which means it will sync with the others and it will receive the right from the other as well. Right? Cool? Cover a lot of things today. There are a lot of technical stuff. Right? Well, it's not done yet. So you see, I told you a lot of concepts. I haven't shown you the real things. So there is one system that is very popular in terms of sharding and replications, which is the MongoDB. Right, MongoDB. MongoDB has a lot of things on sharding and replication. So let's say this is from the MongoDB documentations. So this is an application read and write onto primaries. So primary basically is a read and write in MongoDB, and then the primary will replicate onto secondaries. Okay, and they have like some elections policy, right, that trying to vote for the new primaries, right, when the primary failed, right? So the way that it know which machines fail is that there will be something that they call heartbeat, in which it's more like they're trying to keep checking the other whether the other alive or not. Okay. So there is another thing in MongoDB called read preference. Read preference means that which machine should the application read from, right? For example, in MongoDB, you can set it up at, okay, application, you should only read from the secondary only, right? And this will be good because you know that the data, if you read from the secondary, then you get what? You get the data that is, it's not the latest one, right? You get the data that it's solid, right? Because in the primary, then the data in the primary may be very fresh, right? But data in the secondary may be a little bit old, something like that. So it may not be good, but it may be good in some situations. Okay, we will talk about it in the MongoDB lab, right? For the shardings, MongoDB, they didn't use table. They used the word collections. Okay, so for example, in MongoDB, right, they can shard it into multiple shards. They will have the server here. For each shard, they could have the primary and the secondary copies, secondary replications as well. So replication can be done for each shard, right? And this is the hash sharding in MongoDB. So each data come to hash function and then put it out into the chunk, the partitions. So here they use the word chunk, but that's the same as a partition that we discussed. Okay. This is range sharding. So basically this is one thing. So range sharding that MongoDB do is like you can define whether, okay, the first shard is from minimum values to 10, not 10, to less than 10. And the next one is 10 to less than 20. The next one is from 20 to the maximum values of that field. Okay? So this is what in MongoDB. We will see it in action in the lab, in the MongoDB lab. Okay? Well, I guess that's it for this lectures. So what I want to say is that most of the lectures, most of the databases, if you want to improve scalabilities, you may need to distribute it across multiple machines. And there are multiple ways, right? Share out things and share this, right? For share out things, you can do sharding, replications, in order to improve, make the load balance well, also make the availabilities good, right? There are also share this system, in which share this system seems to be not good, right? Because they have an IO bottlenecks. So why do we need to care about share this system? We will talk about it in lecture number 6 when we talk about modern data warehouse. They need to use share this system. They just need to use it, and you'll see why. Functionalities that we talk about today are shardings and replications. Those are key functionalities that for database management system that are share not things. These are only 2 functionalities I talk about today. There are more than this. Okay, there are many more approaches I haven't covered. Right, this is an introduction to big data cost, so there are like something much more. Right, but I hope you got something. I hope you got some ideas on solving the issue of volumes of data, right? High volumes of data. Okay. For the project, for your cost project, you can also do sharding and replication as well, right? You may find some applications and then try and do sharding and replication. That is fine as well. That would be very interesting. You can try to do some research as well, right? Finding new way to partition data, right? Finding new way to replicate data to minimize, like, to maximize availability. That could be research project for this course as well. Okay. Right. I think that's it for today's lectures. Any questions, comments, concerns?